everybody. Welcome back for another deep dive.
It's great to be here.
Today, we're going to be talking all about equipotential grounding.
One of my favorite topics.
Yeah, we actually got a really great article sent to us from Incident Prevention magazine. It's called Equipotential Grounding, Lessons Learned in the Field.
Awesome.
And it's by a lineman turned safety expert. So, yeah, he's been in the field. He knows what he's talking about.
Very cool.
And we're going to be kind of dissecting the why behind grounding. We're going to go beyond just, sticking a wire in the ground.
Right.
And talk about some real world scenarios and some things that I think might even surprise you.
Definitely more nuanced than just a wire in the ground.
Yeah, I mean, you always see those signs like danger, high voltage, but it's the grounding that really makes it safe to work on those lines, right?
Exactly. And think about this. You're working on a line and suddenly there's a fault and that voltage is going to spike and that electricity is looking for the easiest path to the ground, and sometimes that path could be you.
Okay, now that's a scary thought. So equipotential grounding is basically like creating a zone where the voltage is equalized, so it's not so appealing for that electricity to flow through you.
Exactly. It's all about worker protection and making sure that you're safe, even if something goes wrong.
So the article mentions these two key elements. You've got low impedance worksite grounding, and then you've got worksite bonding.
Right.
So what's the difference between those two?
So low impedance grounding is really about limiting that voltage spike during a fault and giving those safety devices a chance to trip so that everything can shut down quickly.
Oh, so it's kind of like providing a detour for the electricity.
Exactly.
Okay.
Guided away from the worker.
It doesn't creating that path of least resistance increase the risk of a short circuit somewhere else?
That's where the design and the installation of that grounding system really comes into play.
Oh, okay.
It's carefully engineered to handle those fault currents safely and direct them to the ground without creating additional hazards.
Got it.
Yeah.
So now what about worksite bonding?
Okay, so worksite bonding, that's where we create that equipotential zone,
Okay.
or the EPZ, by connecting all the conductive objects in the work area. So it's like creating a safety bubble where the voltage is the same everywhere, so no potential difference means no current flowing through you.
So everything's at the same potential.
Exactly.
Okay, and that's crucial because the article was pointing out that the human body can be a really good conductor.
Unfortunately, yes. And even more concerning, the article points out that the grounding itself is the most critical element. If that ground connection fails, you're in extreme danger.
So it's like your lifeline.
Yes.
It needs to be rock solid.
Yes.
And it's interesting because the article actually goes into a little bit of the history of grounding. And they were talking about how back in the day, linemen used to use chains.
Oh, wow.
For grounding. Can you believe that?
It sounds pretty primitive compared to the methods that we use today.
Right.
But, it kind of shows how far our understanding has come. We're dealing with much higher voltages now, more complex systems. And the knowledge we have now is based on, years of experience and lessons learned, unfortunately, from incidents that have happened in the past.
Right. It's a stark reminder that, safety practices, they're always evolving.
Absolutely.
And speaking of challenges, the article really emphasizes the complexities of worksite bonding, particularly when you're working on wooden poles.
Yeah. Wood is a tricky material because its conductivity is so variable.
Right. It's not like metal.
Exactly.
Yeah.
Factors like moisture,
Yeah.
the age of the wood, even the type of treatment that's been applied to it.
Oh, wow.
All of those things come into play.
Yeah. So creating that reliable bond on a wooden pole can be a real challenge.
It can be a real puzzle.
So how do you ensure that you have that solid connection when you're dealing with such a dynamic environment?
Well, there are a few things to consider.
Hold that thought, because I think this is the perfect place for us to take a break, and we will pick this discussion up in the next part of our deep dive. We got more to unpack, including that surprising fact about energized, grounded lines, so you won't want to miss it.
I'll come back.
All right, so we were talking about all the factors that can impact the conductivity of a wooden pole.
Right.
So how do you actually make sure that you have a good, solid connection?
Well, one of the biggest things is placement. You want that grounding connection as close to where you're working as possible.
Okay, so distance really matters.
Absolutely. It minimizes that impedance.
Yeah.
And it helps to create that stronger equipotential zone.
So what are some other things linemen should be looking out for?
You always want to inspect the pole itself. Look for any signs of rot or damage or excessive moisture. All of those things can really impact that conductivity and weaken your connection.
So it's not just about hooking it up and assuming it's good to go.
Right. You really need to assess the situation.
You got to check it out.
Each time.
And the article was also talking about using those specialized grounding clamps that are designed specifically for wooden poles.
Yeah, those can make a big difference because they really bite into the wood more effectively and they create a more secure connection.
So speaking of things that can kind of throw you for a loop, let's talk about that surprising fact you mentioned earlier about energized grounded lines.
Right.
The article actually states that even a grounded line can still carry a significant percentage of the original voltage.
Is one of the biggest misconceptions in the field.
Really?
Everyone thinks a grounded line is safe to touch,
Ah, fuck.
but even a small percentage of a high voltage can be lethal.
Oh, wow. So even though it's grounded, there's still a risk.
Exactly, and that's where the equipotential zone really comes into play. It acts as a safety net, even in those less than ideal situations. By minimizing the potential difference between you and that grounded line, it reduces how much current can flow through your body.
So that EPZ is really the hero of the story here.
It is, and it's even more crucial when you think about situations where establishing an EPZ isn't even possible, like when you're dealing with downed conductors.
Right.
The article talks about that a lot, and it really highlights the importance of insulation as that primary line of defense.
So things like insulated gloves, insulated tools, that special footwear, all that becomes even more critical in those situations.
Exactly. It's
Yeah.
all about creating a barrier between you and that electrical hazard.
But the article makes it clear that you shouldn't view insulation as a replacement for proper grounding.
Right. It should only be considered a substitute when every other safety requirement is met. It's about layering those protections.
Not choosing one over the other.
Exactly.
And the article was specifically talking about dielectric footwear. Why is that so important for linemen?
It provides that extra layer of protection,
Yeah.
especially when you're working in a situation where you could accidentally come into contact with a downed conductor. Even if you're wearing insulated gloves and that conductor is grounded, it could still come into contact with your legs or your feet. So dielectric footwear really helps prevent that shock from traveling through your body.
It's like backup protection for your backup protection.
That's a good way to put it.
And then there are the challenges that come with working on underground systems.
Right.
It's a whole different ballgame down there.
It is.
The article talks about sheath continuity and this thing called transfer of potential. What is that all about?
It gets a little technical, but basically it's about making sure that grounded conductor, or the concentric neutral that surrounds those power conductors in the underground cable, stays intact.
Okay.
If there's a break in that neutral, you can have voltage transferred to other metallic parts, creating a shock hazard where you really weren't expecting it.
Can I imagine trying to bond across that neutral and establish an EPZ in like a ditch full of mud and water is not an easy thing to do.
No, it's not. Those conditions make it extremely difficult to achieve reliable ground connections.
So what's the solution in those kind of situations?
The article suggests that total isolation of all energy sources and ground sources might be the best option.
So basically just disconnecting everything before you start working.
Exactly. But the article does emphasize that this approach has to meet very specific safety criteria. You can't just flip a switch.
So it's a lot more involved.
It requires those jackety cables that provide that extra layer of insulation and a very systematic process to minimize the risk of human error. Any mistake could have some serious consequences.
Right. So the takeaway is that when done correctly, this total isolation eliminates the need for an EPZ altogether.
Yeah, because you're removing the source of the hazard entirely.
You're just taking it out of the equation.
But, even with all the right equipment and procedures in place, there's one factor we can't ignore.
The human element.
Exactly.
And, the article really talks about complacency being one of the biggest dangers when it comes to electrical safety.
It's so easy to fall into that trap of thinking it won't happen to me, or I've done this 1,000 times before, But electricity doesn't care about your experience or your assumptions. It follows the laws of physics, and those laws are unforgiving.
So how do we combat that human element? How do we make sure that we're not letting our guard down?
Well, a lot of it comes down to awareness. We need to be constantly reminding ourselves of the risks.
Yeah.
Never assume a line is de-energized just because it looks that way. Always test before you touch.
And what about training? What role does that play in preventing those "it won't happen to me" moments?
Training is absolutely crucial, and it needs to be comprehensive.
Yeah.
It needs to cover not only the technical aspects of grounding, but also the human factors involved.
So not just how to set up the equipment, but also how to recognize those moments of complacency.
Exactly. And that training needs to be ongoing. The electrical industry is constantly evolving, and we need to make sure that workers are staying up to date on the latest safety practices and technologies.
And the article also emphasizes the importance of communication.
Right. Clear and open communication between workers and supervisors is essential. Everyone needs to be on the same page when it comes to safety procedures, and if something doesn't feel right, speak up.
Don't be afraid to ask questions or raise concerns.
Absolutely.
Yeah.
It's always better to err on the side of caution. This deep dive has really highlighted the fact that electrical safety is a multifaceted issue. It's not just about the equipment or the procedures, but also about creating that culture of safety where everyone is engaged and empowered to identify and mitigate risks. But we're not quite done yet.
Yeah.
There's one more piece of this puzzle that I think is particularly powerful. We'll explore that in the next part of our deep dive.
So we've talked about a lot in this deep dive about equipotential grounding and all the things that can go wrong and, ways to mitigate that.
Right. It's been a great conversation.
Yeah. But you mentioned there's one more piece to this puzzle that you thought was really powerful.
Yeah. We can talk about the technical stuff and we can talk about all the procedures.
Right.
But there's a quote from the article that really stuck with me. The author writes, "Will this ever happen to you? Only God knows. But your family needs you to come home even if it does. And the EPZ and acceptable alternatives can help assure that."
Yeah, it really puts it all into perspective, doesn't it?
Yeah.
It's easy to get caught up in the technical side of things, but at the end of the day, it's about people's lives.
Right. And that's why we do what we do.
And, we focused a lot on overhead lines in this discussion, but I think it's important to remember that these grounding principles apply to a lot of different electrical work environments.
Absolutely. Whether you're working on underground systems, you're in a substation, you're even doing residential wiring.
Yeah.
The fundamentals of grounding are the same.
Right. You got to have that safe path for the electricity to flow.
Exactly.
And you got to protect yourself from the hazards.
So as we wrap up this deep dive, I want to leave you with a challenge.
Okay.
Think about how these principles we've discussed apply to your own work environment.
Mm-hmm.
If you're an electrician wiring a new home, how are you ensuring that your grounding is effective? If you're a lineman working on an underground system, what unique challenges are you facing?
Right? It's about taking this knowledge and putting it into practice.
Absolutely.
Yeah.
And remembering that safety is a continuous learning process.
Yeah, there's always something new to learn.
Always.
Well, this has been a really great deep dive.
It has.
I think we've covered a lot of important information about equipotential grounding.
We have.
So for everybody out there, stay safe, and we'll see you next time.
See you later.
Anchored in safety. The IP Utility Safety Conference is setting sail to Charleston, South Carolina, from April 29th to May 1st, 2025. Register today at utilitysafetyconference.com.
The views, information, and opinions expressed during this podcast are solely those of the individuals involved and do not necessarily represent those of Utility Business Media and its employees. It is strongly recommended that you discuss any actions or policy changes with your company management prior to implementation.